Welcome back to Quick Workshop. My name is Yuchel. In the last video, you saw me make the lower half of the Squareness Comparator. And today we're going to finish off by building the upper body. Now if you haven't seen the first video, please check it out. We're going to bore out that hole to a couple thousandths smaller than this steel ball. Then we're going to press it in and grind the top half off so that adjustment screw will have something hard to rest on. Before we press in the ball and before we slot the front portion of this, we're going to drill a small hole, and the slot will end right there, and that will eliminate a stress point as you squeeze this tight to tighten the dial test indicator. Of course, we're going to remove away a bunch of material right here to make it thinner too, so it'll make that a stress-free spot. To machine that dovetail, I took an old 2-flute high-speed seal end mill and ground freehand. Just used a single flute and ground a relief around it. Look, it worked pretty well. Now we're going to flip this over and drill a clearance size hole from the other side to the halfway point. We wanted to machine that hole and thread it before we slit it, because once we slit, we would have to put shims in there and it just complicates things even more. We will now narrow down the front end of this piece. Now that we got all the machining done on this small piece, we're gonna slot all the way to the relief hole. Almost made it all the way around, but looks like I'm gonna have to finish cleaning that up with a bandsaw. I probably have maybe 20 thousandths. It's uncut in the middle. I just didn't have the bigger saw blade with the kerf I was looking for, but that's alright. I ended up narrowing right there because I didn't like how much force it was taking to tighten the dial test indicator. So I took I think it was a 3/16 inch end mill and just necked it down, and it works much better. Let's install the steel ball onto that piece. A little bit of Loctite 648. Make sure we get it on the sides. We'll use that aluminum block so we don't damage the vice jaw. And all we have to do is just grind it off with the surface grinder after the Loctite cures. Let's chamfer that nose. I think that turned out alright. Part is upside down, and this is where the spring steel flexure will mount, and I want to put a preload on there, so I have this mounted on the vise at a 1-degree angle. So we're going to machine a 1-degree angle slope here, so the fine adjustment screw would have that preload. I should have done that before I slitted this, but I just completely spaced it. So I'm using some shim stocks to fill the slot that I had machined. Shooting for a 190. Apparently my die is damaged. it just totally destroyed the thread as I was backing it out. Fortunately, I have a neighbor who works on custom motorcycles. He lent me his. With the lockdown and all that, it's not like you can just go and buy another one today, so we'll give it a go. Well, it doesn't want to come out. It's in there. Neurals are not the best, but that's the best I can do with the tool I got. Here's a better view of the hardened steel ball at the end. That'll ensure it turns nice and smooth and you don't have a skip and a hop on the dial test indicator needle. The second one came out better. Let's take a look at what we have. You've seen me make everything here except this. This is a flexure plate that'll connect these two pieces together. And it is, I think generic name is spring steel. And I bought it in an annealed state, so it's easy to machine. So I drilled holes, cut to the right size, and then I heat treated it to make it a spring steel. So nothing too exciting there. And as far as these pieces go, I gave them a quick rub on sandpaper with WD-40, and then I took it to the 3M Scotch-Brite buffing wheel on the bench grinder. I'd say probably 30 minutes on the sandpaper and 10 minutes on the buffing, deburring wheel, whatever you want to call it. Turned out pretty good. So let's put this together. We'll add a little oil. You can better see why I chose to machine the bottom of this piece at 1 degree to put that preload. So we have a hardened steel ball at the end of this adjustment knob and another one on top of this piece, and they're resting on each other. Gives you that real nice smooth adjustment action. Let's mount a dial test indicator. Here they are. I think they turned out pretty well. I'm very happy with it. Now I can see where I made mistakes here and there, but it's my secret and I'm not telling you where they are. I appreciate you hanging out with me in my shop. Please like and subscribe, and we'll see you next time.